Morning, everyone. Thanks for coming. Today you're going to learn about how to make your applications go faster. We're going to talk about Memcached and ElastiCache, and then you'll hear from Khaled Al-Quadoumi, who's the SVP of Technology of Healthguru, about how they've scaled their applications. And my name is Rahul Pathak, and I'm the Senior Product Manager in Database Services, and I've worked on ElastiCache and RDS. So let's get started. First thing I'll do is give a very quick overview of caching, and then we'll talk about Memcached, how ElastiCache can help, and then I'll also talk about some of the common use cases that we see and ways that we see people using Memcached and ElastiCache productively and some common gotchas to avoid. So at its core, cache is a very simple thing. It's a way to speed up your applications by storing data in memory, and it's a way to reduce load on your database. And like all of us, we want our applications to go faster, and we want our users to have more responsive applications. And typically, caching provides the most benefits when we're dealing with applications that are read-intensive. And most apps that we see today tend to follow that pattern, often as high as 80 to 90% read-centric. And as we all know, memory is orders of magnitude faster. We'll get responses in microseconds instead of milliseconds. Conceptually, caches are simple. You start off with a cache that's empty, thinking about information that doesn't change all that often. So for example, a phone number. The first step is to look in a cache. Since it's empty, we'll have a miss. We then go to the database. We update the value, store it in the cache. And then for subsequent accesses, we're just going into that cache to get the information, and we save the DB hit and can focus on just getting that information directly out of the cache. So now one of the things that we run into is what happens when a number changes. And so now what you have is a situation where your cache is out of date, and you've got to go back to the database to get the new information, update your cache, and then you can proceed as before. And so that brings us to one of the issues with caches, which is that while they can provide significant benefits in terms of speed-ups, you have to maintain coherence of the cache and make sure it's consistent with the information in your database. So Memcached, if you're not familiar with it, it's a free, open source, high performance in-memory key value store, and it was developed in 2003 by Brad Fitzpatrick for LiveJournal as they were scaling, and it's used by many of the top sites in the world today: YouTube, Facebook, Netflix, Twitter. All of them use it to provide low latency responses for their customers. And from an architectural perspective, Memcached has two components. There's a client-side piece, which is an API and a client library with some pretty simple operations: sets, gets, updates. The client knows the location of all of your cache nodes, and the cache nodes are independent, so they don't talk to each other. What happens is when you're trying to store data in the cache, the client figures out which node that data should live on, and then the data is stored in the cache at that place. When you go to do a lookup, the client can figure out which node to go to directly. There are a couple of ways to set up the hashing schemes. There's the simplest one is a modulo method, where the key is basically rotated across each of the cache nodes. That's typically not recommended, because what happens is if a node goes down and you have to redistribute your cache, you're going to have a complete reshuffling of everything. And so consistent hashing is the way to go. And most clients support both variants. And that's something that we recommend. And then within each server, the cache is an associative key value array. And you can store arbitrary data in the cache, but essentially it's just a simple lookup table. And the other part to remember is that by default, Memcached is least recently used, so the information ages out of the cache, and there's no persistence in the system, and so you have to keep it. You have to maintain data. You have to just assume that that data can go away if the cache does, and have it persisted elsewhere. You can store arbitrary data in Memcached. It's not just about database query results. It's also about HTML snippets. A couple of things to note: your keys are limited to 250 bytes in size, and your values are limited to 1 megabyte. However, you can chunk them and then use multiple, store larger objects. You just have to maintain splitting and rejoining within your application. So ElastiCache. ElastiCache is a fully managed web service that allows you to create Memcached compatible cache clusters in the cloud. And it's a pay-as-you-go system, as with all AWS services, designed to allow you to scale up as you need, pay as you grow. The diagram that you're seeing here is how a typical application will be deployed. And so you have your users, your web front end is on EC2. That's set up within an EC2 security group. And your application stack is where you'll have your client library, which has your API, where you have your Memcached node configurations. You then have a cache cluster, which has its own security group, and that's a benefit of ElastiCache relative to Memcached by itself, is that it's by default secure, and you have to allow it access. You have to allow your application tier to have access to your cache. Normally, Memcached runs wide open, and you have to deal with security by yourself. The other thing that we provide as part of ElastiCache is metrics in CloudWatch, so you can keep tabs on hit rates, eviction rates, what's happening, whether some nodes are being used more than others, and it's a way to monitor your system. And the primary benefits around ElastiCache relate to manageability, and so it's easy to deploy, simple to do within the AWS console or using APIs. Migration is straightforward. We've designed it to be completely compatible with Memcached, and so if you're already using Memcached in your applications, all you have to do is update your configuration with the endpoints of your ElastiCache nodes, and your application should work as is. It's easy to administer, and so what you have is we have observers that monitor your cache nodes. If there's ever a problem, we will replace them. And that's also something to keep in mind, is a lot of people think about using Memcached in a failover mode. So for example, if a node goes down, they have it configured to go to a different node. That's typically not a recommended practice. Because you don't want to have cache data being shuffled around. It's normally best to wait and tolerate slightly higher latency on a small percentage of your requests than to completely reshuffle everything for everybody. And I'll talk a little bit more about that when we get into some of the gotchas. ElastiCache is also easy to scale. It's trivial to add a new cache node. One of the challenges that we've had in the past is when you do add or remove nodes, you do have to update your Memcached configuration on the client side. And I'll talk a little bit about a new feature we just launched this morning that actually makes that problem go away and should provide a lot of benefits to customers that are looking for scalable caching solutions that move up and down more easily. And then on the security side, it's easy to secure and control access to your Memcached layer and to decide what aspects of your application and architecture will be able to talk to it. Another big benefit of having your caching system live in ElastiCache is that all of your application endpoints and your web servers can talk to the same cache, and so you get the benefit of a distributed cache system without having to maintain it on each of your individual servers. So common use cases and design patterns that we see. We really have ElastiCache customers in a range of different categories. Social networks, as you can imagine, they have a large volume of users reading and writing and interacting with content, and for them, low latency is critical. On the gaming side, we see ElastiCache used very often here for providing fast responses and for maintaining transient data, such as what actions people have taken, scores, things like that. Media sites, again, these tend to be very read-centric, and they need to provide low response times for their customers, and Khaled will talk about their particular experience in detail and dive into some of the architecture decisions that they've made. Portals, again, cache content is the key here. Typically what you see in any Q&A site is a ratio of writers, people that are responding to questions, versus readers is very heavily skewed on the read side. When I worked in a past life at a Q&A and review site, we typically saw only 1% of people were actually generating content and the rest were consuming it. And so those sites benefit greatly from caching as well. So recommendation engines, here there are a couple of interesting use cases. We typically see customers storing expensive computations and intermediate results in memory. And so because you don't want to have to recompute every time, they store those results in a cache and then look them up as they go, again, providing better responses. And then another area where we've seen a lot of growth is with mobile apps. And so again, here, you've typically got a much lower bandwidth connection to the mobile device than people have on their machines at home, and so providing fast response times and low latency becomes critical. So here's a typical gaming deployment, and it's also a way to see how you can combine ElastiCache with a range of services that we offer at AWS. And so walking through the system from the bottom left, you've got users coming in to a load balancer. And that's connected to their front-end application layer with an auto-scaling group. And so that can scale up and down as their traffic changes. The web tier is connected to an Amazon ElastiCache stack, again, to have their low latency response times for things like scores, player actions, what a player is currently doing. And that's typically used in front of Amazon RDS, which you can see here set up in a multi-AZ setting. And multi-AZ is an RDS feature which allows you to have a hot standby in a second availability zone in the event of any issues. And typically what you have is dynamic content with low latency coming out of ElastiCache, but larger objects coming out of S3 and CloudFront. And so these are composed together to provide a rich gaming experience, but also be able to provide high responsiveness. So common design patterns and use cases that we see. One very common use for ElastiCache is maintaining web server session state. And so this allows you to keep user sessions in your cache and in your database. And what that means is that your front-end tier can be stateless. And the advantage there is that it allows you to be much more scalable and responsive on the front end, while still maintaining a low latency pathway for what a user's actual session is doing without having to go to a database to get it. Again, state management comes up very often. People are having rapid interactions, and rather than deal with a round-trip latency to a database every time, operating out of the cache in that scenario is important. One thing to remember is that you do want to provide persistence, and you do have to manage that at your application level. And so, but you can do that asynchronously and use the cache to get response time, but still use the database for persistence. And then the final part, another one where we see lots of usage, is in maintaining things that are expensive to compute. And we see this a lot in social, for example, lists of most popular restaurants. Those things are expensive at scale, and people keep those around and update them periodically and serve them out of cache. Picture IDs, again, tagged, keeping track of a large data set that's changing. That's another thing that people do often. So anti-patterns. This is an area where we talk to a lot of customers, and we help them troubleshoot issues that they run into. And what we see fairly often is that people assume a certain amount of latency or a certain percentage of cache hits, and so design their applications in a way that end up making them somewhat brittle. And so what we recommend is that you should assume, especially in a distributed environment, that you may need to deal with unpredictability from time to time, and build in your application logic to allow people to deal with that. You're typically dealing with complex distributed systems, and there may be different amounts of bottleneck, different amounts of traffic, different objects being requested. And so having the application have some graceful mode of dealing with unexpected events is what I'm talking about on that front, and we can circle back to come into it later. Another issue that people run into is not really thinking about maintaining consistency. How long should an object actually live in your cache? And Memcached and ElastiCache allow you to set a time to live, which essentially lets the cache know when an object has expired. And this helps you maintain consistency on the cache side, because you can set a time to live that's appropriate for the type of data that you're dealing with. And so don't serve stale data to your users and to your customers. Another area that we see people do something that's suboptimal is when they sequentially send single operations to the cache. And so what happens here is you have the overhead of making a request and waiting to get a response, whereas Memcached and ElastiCache APIs provide you the ability to do batch operations. And so you only incur the connection overhead once and get back multiple result sets. And then I talked briefly about this redistribution for when nodes go down or if they're unreachable. Generally, the best practice is to set up your client so that it waits, because typically some of these things are transient. And in the case of ElastiCache, we monitor your nodes and we'll replace them in the event of any issues. And so if you have a distributed setup, waiting is best, because typically only requests going to a particular node will be affected, whereas the rest of your application can perform at a very high performance level. And so that's something that needs to be managed at the application level. It's really up to you, but it is recommended. And then error paths. Again, make sure that the application doesn't fail or freeze if there's a timeout or if something happens. Really, it's about planning for things that you may not have expected to occur and allowing your application to go on so that it at least While some portion of your users may have a suboptimal experience, for the vast majority of them, things are functioning well. So some things to note when you're configuring ElastiCache. So Memcached requires memory for every connection, and that's something that you have to configure independently. So it's important to think about what your usage pattern is going to be, how many connections you expect to have open at any one time, and we expose a lot of the parameters that you need to configure your Memcache server, and you can do that within the console. Another assumption that people make often, and Memcache has binary as well as an ASCII protocol. They often assume that binary is faster, and that's not often the case, and a lot of that's related to batch operations that we just talked about and the overhead of having to do everything sequentially. So it's really just important to understand your use case and to test it and profile your application to see what will perform best for you. So some best practices. One is share your objects. So with ElastiCache, you have a caching layer that sits below your web layer, and all of your web servers can talk to the same ElastiCache cache cluster. And so by sharing this cache cluster and providing all of your web tier access to it, you can actually benefit from usage patterns across all of your tiers. Think about your times to live. Think about the memory you need for connections. The other thing is take advantage of CloudWatch. Set alarms. Don't be surprised when things happen. We provide a lot of metrics in terms of how your cache is performing, and Khaled will talk about how they've used some of those. Consistent hashing we talked about, and the main benefit here is that if there is a problem with your node, consistent hashing minimizes the impact on your cluster. So in a modulo hashing environment, if you had 6 nodes and one went down, your modulo denominator changes, and so the cache would actually reshuffle all of the data in the cluster, and that would create a massive problem on the application side because every single user would have a negative experience while data is being redistributed. Whereas in a consistent hashing model, only nodes adjacent to that would be affected, so the majority of your users wouldn't have any trouble. And one other thing, this is a new feature that we just launched, auto discovery. That was launched this morning, and that's something that I highly recommend you use, and I'll talk about how that works. So auto discovery, so one of the things that we hear a lot from customers is that, yes, ElastiCache is great, so is Memcached, but we really dislike having to update our application configuration every time we change the node counts in our system or every time we need to scale. And so with auto discovery, what we decided to do was to create a system which allowed customers to dynamically change the number of cache nodes in their cluster without having to change their applications or without having to restart them. And one of the big benefits with the way that we've done this, which is to provide configuration information on every node in the cluster itself and then provide a smart client that's able to automatically update itself, is that you get all of the benefits of a dynamic solution. You only have to provide one endpoint, but you don't pay any of the penalties associated with a proxy-based solution. You don't have a bottleneck, or you don't have CPU and network transaction overhead. And so we're really excited about this. It's currently available in Java and with a new Memcached version engine. We are also actively working on a PHP model and looking for people to participate in a private beta of that. So please let me know if you'd be interested in doing that. And we plan to add support for more languages in 2013. So with that, I'm going to turn over to Khaled Al-Qadoumi.
Great. Hello, everyone. I'm going to be talking a little bit about how Healthguru used ElastiCache to solve a problem we had with one of our verticals. Let me tell you a little bit about our agenda for this particular presentation. Primarily, I'm going to be talking a little bit about our company and then about a product that we developed for syndicating our video. I work for a media company, so there's actually only one picture in my presentation. My wife claimed that I will lose all of you as a result, but I'm going to kind of try and engage you with my dialogue instead. So let me tell you a little bit about Healthguru.com. We're the largest provider of health information via video on the internet currently. We serve about 100 million videos a month, and we just started syndicating those videos at the beginning of 2011. So we've seen a rather exponential growth in the use of our video on other health sites. and that's really what I'm going to talk about. We produce all of our videos in-house, so we have a library of about 3,200 videos right now. We shoot them all, we film doctors, and we produce approximately 100 a month. So it's a relatively small body of content, but it's really heavily distributed. We also develop web products around this content to encourage users to find the kind of health information they're looking for. So we've built products like quizzes, surveys, slideshows, a video Q&A product that helps users drill down into the video question that they're interested in getting answered. And all of our content, because it's health-oriented, has a lot of surrounding metadata with it. We have to carry along a lot of medical keywords. We hold transcripts. All of the content has information about who the expert is and what their qualifications are, so that we can make sure that people are confident that the video they're watching is actually expert in nature. Okay. So in 2008, we developed a platform to serve video on the web. We called it, in 2010, we completely revised it and changed the way that we did it. And at that time, we also adopted Amazon as our solution. We were really growing, and we needed some scale. So Amazon Web Services was a logical choice for us. The whole platform, the core platform, is built on LAMP. We use Nginx instead of Apache, and the P is PHP. We use MySQL as our database solution. We use RDS heavily. And our architecture is built on the Zend framework, which, incidentally, if you're not using a framework for your PHP, Zend is really great. It has a whole bunch of class connections to Amazon services that really encapsulate a lot of what Amazon Web Services do. Our first platform was called Chocobo. This is because we have a chief software architect who is a huge Final Fantasy fan and forced me to codename all of our projects using Final Fantasy summonable monsters. I don't know. So this core platform that we started with, it was really a content ORM, a CMS, a basic MVC pattern to deliver a website. We had some models that encapsulated things like what health content is and what an expert is. And then some basic core services, things to do imagery sizing, things to transcode a video on the fly. And when we built this platform, we intended it to run on a single web server, supported by a local database and supported by a local solar install and a caching service. Quick show of hands, who's not using Memcached at this point in their web services? So quite a few people are still running with just application and business logic. Okay, so Memcached is super easy to get up and running. Literally, if you're using a web server, if you're using any kind of web serving platform like Apache or Nginx, you literally just tell it, hey, I have Memcached installed. Look here first whenever you make any request. So Memcached is very, very straightforward to get up and running. I'm going to talk a little bit about a special case where Memcached was not quite enough for us. What happened is we have all this great health content, and a lot of other companies, a lot of other websites started approaching us and saying, hey, we really would love to have video on our health site. How can we get it? Initially, we provided an embed, very much like YouTube, where you just kind of get a code snippet and it loads an iframe and it has a little code in it that tells you about the video and you watch it on your site. But we needed a much more enterprise solution. So we developed, we thought that what we were really shooting for was a fully managed partner syndication solution. And this platform was first described to me by our CEO in Q2 of 2010. And his big idea, his big contribution to this was that he wanted to develop a platform where you would get a single embed code and you would only get it once and you could use it anywhere you wanted, and it would intelligently discover what it was supposed to put on that page. Primarily what he was trying to avoid was some of the other platform solutions where you have to use lots and lots of different code snippets depending on what you want to show up on your page. And it's really hard if you're talking to publishers who may have no or very limited technical staffs to figure out how to use even things like feeds. So what his goal was to have us develop a embed code that could be put onto any page and would just figure everything out for the publisher. It was a bit of a challenge, needless to say, and I thank him for proposing that. So how did we go about solving this? We decided that what we would do is we would build something called a placement, a syndication placement, and it would contain 3 elements. A content set, which would describe what the publisher wanted to show up on their site. It would contain a widget, which was our idea of a client-side code that would deliver some kind of application experience to the user. And it would contain a target set. The target set's actually the important part here. It's a list of URLs that we would check to see if the placement matched what we were being asked for. So, for example, if the client said, hey, my website is www.example.com, and whenever my widget shows up on the /pregnancy page, I want a pregnancy video. They would provide that in the target set and identify a content set that contained pregnancy videos. We also allowed wildcards in this, so if you were www.example.com/*/pregnancy, we would match anything that had any content in there and ended with pregnancy with that particular placement. So, and then we would build a custom JavaScript application that we would deliver to your end user and they would see it. Siren was what we called this. It's, if you don't know, if you haven't played Final Fantasy recently, Siren is also a summonable monster. What it did is it extended the Chocobo platform, and it added a syndication CMS that included the ability to manage these placements and a reporting layer. It also included a key phrase extraction algorithm. We borrowed this heavily from an open source project that the University of Witikau, I apologize to them if I mispronounce that, in New Zealand produced. We added a DB and ORM for partner-specific data, and we built some business logic and services to support this new kind of vertical that we were building. The end goal was really to just deliver a piece of client-side code to the user that allowed for the execution of the health content experience. Baked into it would be a reference to a video and also styling code and JavaScript that would allow them to interact with this widget and experience the right video at the right time. So we had a great deal of interest in this, and our biz dev and salespeople were able to go out and really pitch this to people, and everyone was super excited, and partners were in love with this really sophisticated idea. The reality, however, was that we had a lot to do server-side as a result. When you incorporate sophistication into any application, you just makes everything slow. And the best way to lose people is to give them a slow experience. Clients are totally thrilled to get something, but they're not at all excited if it happens the day after they made the request. There's a lot to do with our particular platform. We had network latency problems. We had extremely high CPU execution requirements. There were a lot of database requests going back and forth. And as we scaled, we ran into this huge failure problem. So our system has potentially a lot to do. We get a request that contains a URL, and we have to figure out who it's from and who it matches. We have to go and request the partner's page, receive it, parse it, analyze it for what it's all about, and then produce a content set that matches it, respecting rules that the partner has given us for what is appropriate and not appropriate for their site. Then we have to compose an appropriate response strip that compiles JavaScript and CSS together to deliver back to the end user so that they can have this awesome experience. And that takes a little bit of time. So without anything, we were seeing, we use a metric called time to first second, which is this average time till a video played, of 60+ seconds with no cache whatsoever. And we had system-wide collapse when we exceeded 50 requests to the system. So obviously a really CPU-intensive process, really DB-intensive process, and it couldn't work if we didn't use some other kind of solution. So we anticipated this latency, and we built in a Memcached layer. Essentially, When we got the request, we looked at who it was coming from and what the URL was, and we generated a hash key to store in Memcache. This is really a great way of storing keys, by the way. If you have some kind of parameter like a URL that you're trying to keep track of, hash it. We use SHA-1 and use that as your key. As was mentioned before, the 250 byte limit on the key actually comes into play when you start using the keys in a dynamic fashion. So hashing is really effective here. So what we did is we generated the key, we went to our local Memcache, see if it was there. If it wasn't, we told the server to process the request and generate the appropriate script, use the hash, set the key, put it into Memcache. If we did get a hit, we just fired off the JavaScript that was stored in the slab behind the key and sent it to the user. That process was really quick, and we had used this very effectively to speed up our website. However, with this particular application, we ran into immediate problems. So the big problems that the way that Memcached distributed with this particular platform was that each server contained the entire Siren platform code and a locally installed Memcached. We instantiated all these servers as M1 smalls, and they all sat behind a load balancer. This meant that requests to our Siren server pool were arbitrarily assigned to healthy instances. If you've used load balancers and EC2s, this is kind of standard. It just round robins them to anything healthy. And we would auto-scale that pool of Siren servers against average CPU use. So if CPU use climbed above 90%, we would add 2 more servers every 5 minutes until it dropped below 90%. If it dropped below 15%, we would remove 1 server every 5 minutes until we were back down to our base level or CPU use climbed above 15%. So we tried to stay between that sweet spot of 15 and 90% CPU usage for scaling. Again, this had been a very effective solution for us with our web servers. And then behind all this, we had an RDS master with read replicas supporting this architecture. It seemed to us like a good idea at the time, but didn't really work. What really happened here is that cache missed all the time. Because we had this distributed architecture and because we had local Memcached sitting on every server, every request was getting arbitrarily assigned to a server, and if we had 20 servers, worst case scenario, 20 misses, and the 21st finally hits somebody who actually has a server that has your data in memory. The other problem we had is that every server was becoming redundant. All of the memory was looking identical. Every server stored the same data over time. Whatever the requests were, it just built into the same kind of stack of data. And actually scaling this pool introduced more problems rather than less. Usually we think of scaling as a solution. Here it was actually a problem. Every new server we added increased the amount of database demand because it was introducing an empty cache. We did play around when we started doing this with warming the cache, but again, because it was just a redundant warm, it wasn't very effective either. And as we scaled, we also increased the likelihood of a cache miss because, again, traffic's being arbitrarily assigned. If you've got 20 servers, you get 20 misses. If you have 40 servers, well, now you have 40 misses, and it slowed everything down. This lack of pooled memory also meant that we were limited to the cache size of any one given server. So with M1 smalls, I think we have 1 gig of memory available. We have to allocate some of that to the CPU and PHP. The rest of it gets to go to Memcache. So we were finding that we had a memory limit of about 600 megs of cache space. That's pretty tiny. And we filled that up really quickly, and then we didn't know what to do. And as soon as you fill up cache and you start trying to shuffle new things into it, you get into an eviction problem. If you've used Memcached, this is what happens when you have a full cache. Memcached starts to look through your table and find out what the oldest piece of data is in there and evicts it and adds your new piece of data to memory. You really don't want to have evictions happening because it means that content that shouldn't have expired is being kicked out. And we had relatively short expiration times on our Memcached units. I think they were set to just 6 days or something, which isn't horribly long for cache, but yeah, we just couldn't handle the eviction. So we knew we had big problems. Very quickly, we knew we had big problems. And we started looking for solutions. At the time, the premium solution was something called Membase. It's a CouchDB kind of operation that lets you take a bunch of servers and sit CouchDB in front of them to manage Memcached across a bunch of servers and use the NoSQL database as your workflow controller. We were going to actually incorporate Membase, but we realized it was going to require a lot of work. There was a lot of code to write to get Membase up and running and to incorporate CouchDB. And as we were deciding that, this is what we've got to do, ElastiCache arrived. Amazon has this bad habit of coming up with exactly the service we needed as soon as we kind of realized we have a problem. So ElastiCache arrived and we implemented it. We experimented with it first and realized as soon as we have a small cluster of dev servers that were running Siren Syndication, and we built a small ElastiCache node and attached this dev server pool to it, and we didn't actually require any changes at all. No code changes, no configuration changes really. We just pointed the Memcached service to this ElastiCache node, and everything worked. And spinning up the ElastiCache node was super easy, easier than an EC2 instance. Yes?
So just a question. So
sure.
You were using Zen Framework, so I'm assuming you were using Zencache, and you were instantiating using Memcached in there. How did you get that to go to ElastiCache if you were using Memcached in Framework?
It was completely opaque. So the Amazon, the Zen Framework is using Zencache. And the references to it actually were, we didn't change them at all. All we had to do was, we're using Nginx, and that Nginx points to the location of our Memcache layer. All we did was change that parameter to point to the ElastiCache location. ElastiCache has ElastiCache, each node gives you a unique URL for its location, and we just plugged that in, and everything worked. It really was transparent. I mean, it was opaque. I mean, there wasn't anything that we needed to do differently except change that one configuration setting in Nginx. And literally all it was pointing to a different server location. I'll talk about a little bit of the problems we had with scaling it, but it was that easy. Zen Framework just worked right along with it. And like I said, the spin-up was super easy. You literally click 2 buttons and you have an ElastiCache node. You just tell it how many you want and how big you want them to be. And the pricing on this was super, super compelling as well. Unlike EC2 instances, the ElastiCache nodes they're also EC2 instances, but they're designed specifically for memory. So they have more memory, they have smaller CPUs, they don't load, the AMI loads nothing else but Memcached, so you're not running anything extraneous. You get almost the entire memory space to use. So the smallest ElastiCache node I think is like 3.2 gigs, and we were seeing pretty much all of that, 3 gigs from that, available for Memcached, which is huge compared to the 500 or 600 we were seeing on an individual EC2 instance. Also, the fact that there were metrics associated with CloudWatch metrics associated with this was awesome. We could see exactly what was going on, and with Memcached, it's sometimes difficult. There are programs that you can use, like PHP Memcached Admin, to help you, but when you have 20 or 30 servers, it's really kind of difficult to see the big picture. And CloudWatch was really helpful with that. So what did it take? Really, we spun up a cluster of 4 nodes. We installed Moxie as a client on all of our application servers. And basically all we did was modify our custom AMI to have Moxie be part of it, and pointed Moxie to the ElastiCache nodes. We installed PHP Memcached Admin, and we had it installed for our Memcached installs, but we just pointed to the ElastiCache nodes, and it worked exactly the same. And other than that, there was really nothing to do. All of our infrastructure remained the same, no code changes, no application configuration changes, very, very modest changes to our web server. And that was it, really. I mean, it literally took us less than a week to install ElastiCache. Truthfully, it probably would have taken us a day if I had a more active chief software architect. Probably playing Final Fantasy that day. But we saw immediate performance improvements. The ElastiCache servers, like I said, are built to handle memory operations, so they're an immediate improvement over your existing EC2s. And the uniform calls were tremendous for us. The fact that now we had a pool of memory that was reliably going to return back a true miss or a true hit was gigantic. Also, the scaling improvements were clear now. One of the nice things about ElastiCache is that you can scale these servers vertically very easily, and that's actually how we use them to start. The small sizes are 3 megs, the largest sizes are, I think, upwards of 60. Gigs, I mean. So the small ones are 3 gigs, the largest ones are upwards of 60. And without any configuration changes at all, you can swap the instances upwards or downwards as you see fit. So if you suddenly hit your memory cap and you've got 4 nodes configured, you can scale them all up as big as you like, and nothing needs to change. So if you've got a problem that needs, I mean, you pay more, obviously, but if you've got a problem, you can scale upwards very easily. Removing Memcached from our application layer allowed us to now scale it with no problem whatsoever. Our application servers started doing what they were supposed to do, which is handle requests, perform CPU processing, and pass that on to memory as needed, not handle memory hit-miss conditions. So the application servers started only getting called when they actually needed to be. And the actual memory pool actually scales horizontally fairly easily as well. We're really excited about this auto discovery, honestly, but because the biggest problem is scaling upwards, not downwards. You can scale downwards very easily. You just remove a node, and it populates the rest of the nodes with what it used to have. But scaling upwards is a bit more challenging. The solution that we had actually to the scaling upwards problem was to use Route 53, which is also an Amazon product for DNS management. There are 2 big advantages to using Route 53. One of them is that you reduce latency between calls to your domain name server and back into ElastiCache. So if you have an external domain name server, you have to call out to that. It resolves your Memcache, then calls back into Amazon. If you use Route 53, that's all gone. It's all within the data center. And also, it allowed us to produce uniform naming conventions for our ElastiCache nodes. So one of the things we did was build a small script that just iterated the number at the end of the ElastiCache node name, and when we needed to scale, we still had to redeploy Moxie, but it was all automated through scripting. ElastiCache also provides uniform access, which means you can manage it with a database very easily. If you need to invalidate or if you need to prevent content deduping, you can build a small database application or just build a small database table that monitors what's in ElastiCache, and then you can use your application to manage it. You can also manage misses very effectively as well. The way we handle this is we just have a default that we load into ElastiCache, and if we miss, we just serve that instead. And we also learned that deploying ElastiCache across availability zones works fine. You can deploy it across as many availability zones as you want, and it'll continue to work as long as you have Moxie pointing to them. This allows you some degree of protection from failure for any given availability zone. So it's really nice to figure that out as well. I'm going to give you a quick case study for a company called DailyRx. They adopted our platform early. They had huge problems with our initial deployment. So when they rolled us out across their whole site, our application stopped working altogether. They loved the idea of this product, but they really were considering abandoning us because of poor performance. We installed ElastiCache, and the average response time dropped from 60+ seconds to under 2. We now record response times of less than 2 seconds for all of our script calls. I think recently when I last looked at this and we expanded ElastiCache a little bit, we're seeing average response times of 746 milliseconds over a 30-day period, which we're really proud of considering that previous to this, the average was something like 32. And we had an incident early with them where they were filling up our cache really quickly, and we were able to scale our cache vertically to prevent an outage. And we later realized they had used a marketing partner that was changing the URL regularly. But we were able to resolve that. Future plans and ideas, we'd like to implement auto-scaling on ElastiCache, and auto-discovery will allow that now to happen. We've thought about using Memcached and ElastiCache across multiple regions to create something like a Memcached CDN. And we also want to try and break up these services into common components and try and assemble things out of ElastiCache instead of delivering an exact hit. We'll see if that pans out into anything. Questions?